Good evening, everyone. And thanks to Nitin and Thomas for inviting me for this talk over here. Okay. So, I'm Nishant. I run a few teams within the engineering group at Salesforce. In the Salesforce for just under 2 years, and primarily my focus is around distributed systems, data pipelines, and event processing. Okay. So, I want to focus today talking about near real-time analytical systems and how sort of Kafka sort of plays a role into that. So I'm going to just give an overview of sort of real-time analytical systems at Salesforce and zoom into how Kafka and where Kafka fits into it. Okay, so let's start from the beginning. So some time back, one of the challenges that we had at Salesforce was there's rapid growth. We are building new data centers, and we run our own data centers, and we wanted to get real-time information on system health. So we wanted to generate some insights into how the clusters are performing, how the hosts are performing in real time, and we wanted to generate those insights from the system metrics that we're collecting. And that was the genesis of what we codenamed as Project Art. And you can read more about what it is, but it's effectively equivalent of a sixth sense, which helps you reveal some insights into what's going on. So what did we achieve when we sort of embarked on that project? And that's the first time when we sort of used Kafka at a decent scale for doing something like this. So mechanism for system health monitoring for all clusters across all Salesforce global data centers. So we developed this end-to-end pipeline and alerting system to help monitor these systems. Health monitoring and alerting for the new clusters was config driven without any code changes. So we continue building our clusters and bringing sort of new data centers online. And one of the key goals was that as we sort of increase our footprint, we don't have to go back and make code changes to understand the health of all those new systems coming up. So we want to sort of deliver it config driven. From event to insight, the end-to-end latency, including sort of network delays, under 10 seconds. So it's fairly quick, and it's one of the key things that is leveraged by the site reliability team. And Kafka is a technology that sort of enabled it in terms of gluing everything together. So we had this thing running, and while we kept on sort of refining it and optimizing around it, one of the things that we wanted to figure out was what else can we do by leveraging this stuff that we had already built. So what was our vision? So our vision is to build a multi-tenant platform to enable real-time scenarios at scale. And when I say multi-tenant, I want to make a distinction. It is not sort of external Salesforce offering, so it's internal to Salesforce, but it's still multi-tenant because we onboard a lot of internal customers and applications for which we can enable real-time scenarios. Okay, so what does that sort of vision looks like? So, and I'll spend some time talking about this. So on your left-hand side, you see there's a lot of data producers. That can be infrastructure devices, data coming from our networking devices, data coming from our host, bare metal services. There are a lot of services that are running within Salesforce that would want to know sort of real-time insights as to what's going on with them. Various application scenarios that we want to enable, whether it is a notification scenario or an alerting scenario or a compliance-related scenario, intrusion detection scenario, things of that nature. And then, leading all the way up to sort of ingestion of data from a perspective of Internet of Things, and sort of bringing really massive scale of data into the picture. And you want to push all of this together, data, multiple applications onto a multi-tenant sort of data broker, which is powered by Kafka, which then sort of feeds this into multiple places. So you can have multiple consumers who do data processing. So whether it is for machine learning, whether it is for text searching, whether it is for data analytics, or you want to run your MapReduce jobs, or you want to do some sort of stream processing, and eventually you also want to store this data for long-term analysis. Whether you want to do 6 month over month, or year over year analysis. And that's sort of what the data flow between them sort of looks like. And eventually is what you want to do with this data. So in most cases, you would want some sort of presentation. So whether you're visualizing metrics on a time series database, whether you are pushing that data into web analytics for external consumption, whether you are driving alerting off of that, or whether you are building sort of autonomous systems who can take that feedback back into the system and take remedial actions and fix things as much as they can in an automated manner. So that is sort of the Uber vision of where we want to head, and we want to be sort of agnostic of what data flows onto the system, and we want to onboard multiple internal scenarios and customers onto this pipeline. So let's drill into a little bit about sort of what is, at a 100,000 foot view of what the architecture is. So on your left hand side there's a gray box. I'm calling it production cluster. So it's a bunch of physical hosts that are logically combined together into a cluster, and each of the hosts has some sort of an agent running for collection of data. So whether you are running collect D for collection of system metrics, or you're running another agent that is collecting log data and then sending it over, it sends that data over to a cluster level Kafka, which is used for data ingestion. Data can be subscribed locally. So if there are certain scenarios where you don't want aggregation of data across clusters, you can sort of subscribe to that data locally. The data is within that security boundary. It never leaves that particular production cluster. Or if you want to do analysis across the board, and if you want to do analysis sort of over a longer period of time, we use Mirror Maker to then push that data into our aggregate cluster. And our aggregate cluster is in a DMZ. And that's where a lot of the internal engineers can then access that data. So whether it is for understanding performance implications of your applications, or whether you want to derive business insights, or whether you want to derive any operational insights. And from the aggregate cluster, you can do again multiple things. You can sort of push that data into a Hadoop-like cluster and then run map reduce jobs. You can push that data into something like a Spark streaming cluster and do real-time stream processing. You can push that data into a time series database for doing metrics visualization. You can push that data into other systems that can help you do alerting. So there are multiple things that can be done. So that's sort of, at a very high level, sort of the key architecture that we follow. Okay, so digging into some of the details. So number of Kafka clusters per production cluster, we try to stick to 1. Number of aggregate cluster in DMZ, 1. Number of topics that flow, that's again specific to the data. So for some scenarios, we have a single topic, and that's good enough. And in certain other scenarios where we want to segregate data based upon customer, then we may have hundreds of topics ranging. Number of partitions, again, how we want to consume data. So today it sort of ranges from 1 to 16. And it sort of depends upon the throughput of the data for a given data type and how much parallelism we want out of that. We have 3 replicas of data across the board. Data retention, and again, sort of depends on scenario to scenario. For certain topics, the data retention is less, and for certain other scenarios, we want a little bit more data retention where we want to make sure that we don't lose that data in case consumers are not up and there's a long holiday or a weekend, so we want to keep it for at least 4 days. What version of Kafka we are running? So we are running a modified version of 0.82 in half of our clusters, I believe, and then running a modified version of 0.9 in the other. And we upgraded from the modified 0.8 to modified 0.9, and the modification that we have done is when we were running on 0.8, we wanted to enable SSL, and 0.8 Kafka doesn't come with native SSL, so that's the change that we had to do. And now we sort of moved to modified 0.9 just to maintain backward compatibility, as we can't afford any downtime, but we are eventually moving to sort of vanilla 0.9 and 0.10 going forward. SSL enabled, yes. Topic level auth. So we have enabled for certain scenarios where the underlying framework is available to us with the 0.9 Kafka. But with the vanilla 0.9 running, we will enable it across the board. And for authentication, we use Kerberos-based auth. Mirror Maker is one of the key components because it's significant volume of data that sort of flows and directly moves to the aggregate cluster. So some more details around it. So not all data is mirrored, so we only have selected topics which are whitelisted. They mirror across. Max message size is 2 MB and we are working on reducing it. Ideally we would want to be a lot smaller than this. Batch messages 500, so once we go the buffer time limit, we sort of buffer all the 500 messages and send it together. Max message size is 2 MB. Our partition strategy is round robin, so that way we can ensure that all the topics are given fair treatment. We use G1 GC with max heap size of 28 GB on the garbage collection size, and then we have modified the 0.82 mirror maker to support SSL. And that's one of the key areas in terms of things that we would want to stick when we move to 0.9, stick to sort of the supported version, support for SSL. Okay, scale, so we have 30 plus clusters, and as we sort of increase our footprint, our number of clusters that we need to support increase, and as we support more scenarios, again the number of clusters that we need to support may potentially increase. Aggregate throughput around 300 Mbps across the system. Average events per day in high hundreds of billions of events. I know Nathan mentioned they're doing 1 trillion plus events a day. We are not there yet, but I suspect within the next 18 months, 2 years, we'll probably hit that point. And our P95 for latency generally is around 30 seconds, and that includes network latency. So we measure latency from the time that you send the data to the first Kafka cluster, and then Mirror Maker picks it up, and then across the network send it to the other Kafka cluster, and it's available for consumption. So scenarios we enable. So the first scenario is what the genesis of the whole system is. So site reliability, visibility into the system health, powers their dashboards, powers their sort of alerting systems, so that they can keep track of what's happening within our data centers. Salesforce also published sort of performance metrics on all the transactions that happen at Salesforce. And this is public data, so you can hit that endpoint and get that information. So we do, I think, last I checked, order of 4 to 5 billion transactions a day. And a lot of that computation of how we derive at those numbers or how we calculate those numbers comes from all the application logs that are generated as customers hit Salesforce. So we use the system to sort of power those calculations and deliver that number. App log analysis for application performance analysis, for generating business insights out of it, both immediate and long term. We are using this system for network monitoring, so you want to sort of collect sample data from our network devices. Security and compliance monitoring to a large degree, so we plan to use another open source technology called OS Query, which sort of gives you OS level information on what version of OS is running, what version of software is running, what firewall ports are open, so how many people logged onto the system, when did it last log on, so on and so forth. So you can generate a lot of static queries where you can do that analysis from a compliance perspective in terms of or security perspective. You get alerted when a code, a malicious code gets open on your cluster. And app-based event communication scenarios. So server-to-server communication scenarios for various applications. So think of it. A good example is you mentioned somebody on the platform, and you want that person to get a phone notification that the person got mentioned. So doing sort of those fan-out scenarios at a large scale is just one example of supporting app-based communication. And then there are more. Okay, operational challenges. Large number of clusters to manage. With each new cluster, there is an overhead of managing it, patching it, keeping it up to date, addressing any security vulnerabilities that come across it, releasing bits to that cluster. So that's one of the challenge. Non-homogeneous hardware. So, and you probably run into this as well. So if you have, let's say, 11 node cluster of your brokers or a 5 node cluster of your brokers, and we are capped by the available disk space as opposed to CPU on how much data we can retain. And if you can't retain for the amount of data that you want for our customers, we need to add more machines to it. But Kafka sort of stores that data in a round robin manner. So if you have, if you have one machine which has, 4 terabyte usable space available for storing the data, and you may have another 3 machines which may have 8 terabytes available, the extra 4 terabytes is a waste. So you got to go with the lowest common denominator. So that's a sort of a continuous challenge where your hardware refreshes every 3 years, and the hardware that you're going to get this year is going to be much superior than the hardware that you got last year. But then you got to have sort of work through, how much you need and how disparate you want that to be. 0.8x mirror maker is sort of buggy, and we are working hard to sort of upgrade to move away from 0.8. So there is scenarios where data loss is possible, especially when the offsets are lost in case mirror maker crashes. So that's sort of an ongoing challenge. No built-in support for QoS, so everything is treated equally. There are things that we can do to sort of make it better. So for example, if we are aggregating everything together, we can have dedicated mirror makers for certain topics. But ideally we would like something more built into the platform. Maybe built ourselves to support QoS. Operations of the boxes are manual, so you need to log on to every box to get an info. And when you're sort of 2,000 machine scale at which Nithin and team are operating, it sort of becomes cumbersome. Lack of traceability of data across the system. So we have a little bit of a complex pipe. So it's like 2 Kafka clusters with mirror maker in between. And if the data doesn't end up on the other end of the pipe into a resulting system, then sort of there is no out-of-box mechanism of knowing where it is. So you have to sort of go through that traceability on the other one, or build some mechanism around it. No self-onboarding for customers. So if you want to onboard new customers, there's nothing that we can readily use, and that's an area that we are working on. And management of multiple Kafka clusters is manual kind of thing. I think I talked about that a little bit. So what are our learnings? Aggregate clusters as much as possible rather than having too many. So that will just help to scale things better. It's better resource utilization. It's less management overhead. And generally, I find if you can do that, it's better. So for example, if you're going to use Zookeeper for maintaining for every cluster, no matter how big or large Zookeeper is, you need to have at least 3 machines. So if you have more number of clusters, then you're spending that much resources in just Zookeeper, which are really not doing anything. Use homogeneous hardware as much as possible for the same reason of the disk usage that I talked about. Mirror maker, upgrade ASAP. Use SSDs where possible for increasing throughput. Even using SSDs on Zookeeper will help in terms of maintaining the consensus, and so doing that checks are much faster. Consider using a dedicated cluster for specific scenarios. So there's no sort of built-in QoS. So if you're doing an extremely low latency alerting kind of a scenario where you want to get notified as soon as possible, I would say probably better to have a dedicated cluster just for that. So it's a fine line depending upon what the business needs are. Should you aggregate stuff, or should you have dedicated cluster for certain latency sensitive scenarios? Consider default number of partitions to be a sum multiple of the number of brokers in the system, and that just helps with sort of the uniform increase and decrease in the disk capacity. So you won't run into an issue where a particular broker becomes too hot because a particular partition became too hot. And a partition can become hot if one of your customers decided to either use a particular partition more for in-order guarantees, or use a particular partition more because they are indexing or hashing your data in a particular way. Monitor everything. And I think for debugging purpose, a lot of the things which are fairly low level can be very useful. You don't have to alert on everything, but you've got to monitor on everything. And the last one is also very interesting, which is don't use Kafka to monitor Kafka. So it's sort of a circular dependency. So use out-of-band monitoring as much as possible, and I'm guilty of it as much as anybody So we use ourselves to monitor ourselves, and it is not good. So monitoring Arjuna, what do we do? So one of the main challenges with running large systems and setting up alerts is the alert overload and the amount of false positives. So it's part science, part art. So see sort of what works for you. But I would say don't worry about host level stuff as long as your service SLAs are being met. You only should be woken up in the middle of the night in case there are issues with the service SLAs. So for us, we sort of consciously kept it very low number, which is just 2. We have an SLA alert if a latency for a given topic increases a particular time limit, or if the throughput sort of decreases a particular time limit. Now, there are customers where the data is choppy, so the throughput would naturally decrease. Doesn't mean there's anything wrong with the system. It's just that system is not generating the producer is not sending the data enough. But then there are other things such as health metrics, which are constantly, on a regular cadence of producing that data regardless of whether anybody is using stuff or not. So if you see there's a throughput decrease, and which eventually, when we measure this end-to-end across our Kafka, MirrorMaker, Kafka cluster, then there's an issue. So usually points to us an issue with MirrorMaker. So the data was received, but then on the other side we didn't see the data. So potentially, either the MirrorMaker is stuck, or it's down, or there's some other issue, or maybe a network issue, right? But keeping it high level effectively helps you to sort of not have too many false positives or any false positives. Also, not be woken up in the middle of the night for something that is not impacting these things. Now, if you have, if a broker goes down, you don't get alerted. If 2 of them go down and you start losing corrupt, it will eventually impact one of these 2. Right? Either the throughput will go down, or your latency will start increasing because things have started to queue up. So regardless, if things are working fine and you don't get alerted on these 2, don't worry about it. At host level, we collect a lot of things. So we use collectd to collect host level metrics, which goes into a time series database on which we can do alerts. So for example, disk capacity. So we run sort of in a heterogeneous hardware environment. So if a particular disk is running low, we would get more. And this is just an example. We use JMX transagent. So JMX beams data, go into again a time series database, and then you can generate alert off of that. We have Nagios process checks, so that sort of go directly into an alerting system. For alerts, what do we use? So we have a homegrown tool we call it Argus. It's actually an open source tool. I have a link towards that. It's a HBase time series database based upon HBase, and we use that for metrics visualization as well as for alerting. So we have sort of email notifications, which we then integrate with PagerDuty, and that sort of thing. We receive a call in the middle of the night, and then we use Argus.
Is Argus the time series DVA you mentioned?
Yeah. So what are the tools we use? So we developed something called Arjuna Auditor. It timestamps every event. So I believe with 0.10 release of Kafka, every event is timestamped by default. We are not at 0.10, but we timestamp every event. So I think it's a step in the right direction from Kafka's standpoint. We leverage some of the core capabilities that Kafka provides in terms of data loss and latency calculations, in terms of data loss and sort of throughput calculations. For our latency, we sort of sample the data ourselves and then derive our latency numbers, whether it is P90, P95, P99, or sort of the max latency that we observe anywhere. So that's homegrown, and I'm hoping at some point we'll probably package it in a decent manner and release our federal pieces. Argus, that's the HBase-based time series monitoring and alerting platform. I'll encourage you guys to sort of check it out. Dashboard creation tool. So we used to use Graphite, now we are using Argus. And one of the initial scenarios that I mentioned was around no code changes whenever you want to monitor new system health, new clusters that come online. So we sort of follow a nomenclature by which the metrics are generated, sort of a naming convention for the topics and for the data that flows onto it, and that allows us to sort of create these tools where we can sort of automatically generate the right alerts and the right dashboards for the new clusters without doing anything. So when the hardware team is sort of building out a new cluster, they run the tool and automatically sort of the new dashboards and alerts come online without us having to make any changes. And in most cases, us not even knowing about it. And then we also developed something called Funnel, which is sort of an HTTP endpoint for ingestion of data into Kafka. So as a generic endpoint where you can send sort of metrics, we're going to sort of expand on that a little bit to ingest different kinds of data and also support the schematization of data and some checks around. So where are we headed? So 10x scale, and it's going to come in the next 2 years, I would imagine. We are going to invest on the management API. So again, a lot of with the increase in the number of clusters and with the increase in the number of size of these clusters, managing all of them is painful. So we are going to invest specifically around how we want to manage our clusters, starting with an API, followed with API. Multi-tenancy, so we want to sort of support and do more work around that. Auth and Auth-Z is clearly an area that we have started off working with the 0.9 release. So we may use different authent mechanisms. Currently it is just Kerberos. We may also optimize some of the Auth-Z related tasks so that we don't have to have the chattiness of talking to Zookeeper every time. So we are looking into sort of namespacing our topics so that we can do some regex-based auth and Auth-Z around it and sort of build a wrapper around that. Throttling, we're going to heavily leverage that given that there's no QoS. We want to at least keep in check knowingly and unknowingly somebody doesn't do a DDoS attack on the service. Finally, sort of build a self-serve UI, a portal where you as a customer can come in, provision a namespace, create the topics, we give some default configurations, with some default retention, and then you sort of tie it up with the right dashboards as needed or the right access patterns as needed. Cluster management API is probably similar. So I think cluster management is what I talked about. Management API is again, there's no good API right now if you want to create topics. So we had auto topic creation on. Auto topic creation in a multi-tenant environment is not a good thing. So we want to turn that off, but if you turn that off, then you need to give your customers access to Zookeeper so that they can then create the topics. And that's something which is behind a service boundary, and we don't want to do that. So you want to sort of build a management API, a REST-based API, so that we can run on topics. And we are looking into Prometheus as one of the other open source systems to sort of a parallel pipe just for monitoring Archnet itself, because we want to avoid circular dependencies. Questions? Yeah.
So you mentioned that the partition number comes to 60. So
that's the max that we have, but you can have. Yeah.
I wonder how you data is ongoing more and more. How you can go to the initial map of the.
So it depends on scenario to scenario. So the question is, how do you sort of determine the number of sort of partitions? So I would say when we are onboarding more customers, we sort of have a default partition number, I believe like 4 or 8. And then if you're a really large throughput customer, then we can sort of handhold them in terms of increasing that number of partitions to more. But again, it sort of depends on scenario to scenario.
Two questions. How do you handle data center-wide outage? And how do you monitor the log loss?
Yeah. So I'll take the first one. So data center-wide outage. So DR is something that we have not invested into it right now, but we are going to invest into what the DR policy is going to be. So one good thing is that we are taking events that are generated within data center X and pushing it out to our aggregate cluster. If the data center itself is down, there's nothing to push. So we can sort of take a little bit comfort in the fact that us being down, if the data center goes down, it's not really the end of the world because there's nothing that we need to push out. But to your point of what if our service is a service that goes down and the data center is still up and running, that again is sort of more of a HA issue rather than an AI issue. On the second question of how do we...
So the first one, if your aggregated cluster, which is also in one data center, right, that is down, but all your serving clusters are up.
Yeah, so that we are going to sort of do multiple writes, sort of a lazy write, and then if you keep our retention to be small over there, and then let's say it's all your data goes into like a Hadoop-like cluster, that itself is DR enabled, and because it's a bus, so the data should only be in a transient state, and then the analysis that you need to do is what's the cost-benefit ratio of the amount of data that's on the bus, using that versus investing into building a completely separate cluster and a pipe where you sort of mirror that data multiple times.
Is Mirror Maker Kafka component or is it something that you do?
It's a Kafka component.
And does it cause any performance issues because you're adding one extra layer of replicating Kafka?
Yeah, so Mirror Maker is effectively, think of it is a consumer and then it is a producer, so combined into one, right? So does it cause any performance? And by performance I would say latency, and the answer is yes, right? So there will be a hit because you're first reading it, putting it into your internal queue buffer, and then you're sort of producing that data out. Why we had to do Mirror Maker is because if I sort of go back to so the production clusters are for us high security zones. A DMZ is a low security zone. So by the security policies under which we operate, I could not open a connection from a low security zone, DMZ, into a high security zone. So I cannot pull any data. Otherwise I could have just subscribed to a topic. So the data has to be pushed from a high security zone to a low security zone, and that's why we use it. So it's more of a security consideration for us.
Also, the Argus tool, is it open source?
It is open source.
And is it good only for the Kafka-based monitoring, or is it?
No, it has a REST endpoint. It is a metrics visualization tool, so you can use it for metrics visualization. As long as you're pushing any time series data into it, you can use it. Kafka could be just one of many points from where the data is coming. So it has a REST endpoint. You can just write your REST application and push data.
So I have a quick question, so do you guys do the reconciliation, like you have a 4-day retention policy? I don't know whether you have a transaction data which you're pushing into the system or not, but we have a scenario where you're pushing a real-time transaction data back to the Salesforce for our campaigns and all that one. So there could be a loss of product, might be. So in that case, how do you do the reconciliation? How do you have not?
So this is not transactional data.
That's not transactional. But
Yeah.
are you using the transaction data?
We do that. We have highly monetizable data through Kafka.
Okay.
And how you guarantee that it goes through system?
Right.
So data is going through multiple stages. Right? You have to guarantee at each stage there is no loss.
Right.
Now, absolute no loss is not possible with point A, like you mentioned. But with later version, you can tune Kafka high number of applications, making sure that when a message is sent to Kafka, you only act back when it's replicated to all the replicas. And even on the consumption side, you not use mirror maker, but you use something more reliable, which is guarantee that the data is pushed out only when it proceeds. So we have done those things, and we run our monetization pipeline on top of it. And our guarantee is there is 99.8% or so.
So I'm going to touch base with you because you're building this pipeline with a real-time transaction.
Yeah, so I think two things. So what we also run sort of in a act mode. So we, when you first send the data to Kafka, we sort of, act only when the data has been written to all the replicas. The other thing, when you build such system is also to have the ability to replay the data. So if you recognize that look, there has been a loss, then you need to be able to say, I'm going to replay the data from a particular offset from my producers and send that data back. And I think that's a hard challenge, and it depends on what the business scenario is. So like Nathan mentioned, in that case, if it's monetizable data, then every data is effectively some revenue, and if the data is lost, then there is a revenue loss. If you're pushing system health metrics and there is a data loss, not that important.
That's true. Like we are talking data we push to Kafka and lost some money, but transactions we need to
Right.
There's a
100% you won't be able to, but you can get close to it.
there's a talk from Kafka Summit that comes security about how to configure for scenarios. It'd be a good thing to watch. But I guess by transaction you can mean exactly once. You don't want to take it in the system. That's just not possible in Kafka, I guess. Because since you're pushing messages into Kafka, there can be scenarios where you use the act back from the Kafka broker, and you just don't know if Kafka actually wrote that message to the disk or not. So the producer will definitely get back when you get two messages in the Kafka system.
Yeah.
At least once.
Not exactly.
When I talk next, there's some stuff we do that we've been looking at with log compaction and using DVA to help do exactly once and also fill in those non-joinable holes in your processing pipe where you're between two things in memory and there's an out-of-order processing needed back in the queue that you would not need to that kind of stuff.
So you got to build a lot of machinery around the system to sort of, depending upon what your scenario is.
One last question.
Yes.
You mentioned you have 50 or so some clusters, right?
Yeah, 30 clusters.
How bad is your DRI?
How bad is the DRI schedule? So, see, we have weekly rotation for the engineers. It's a fairly small team, 8 people team right now. We have 4 people team 6 months ago. Depends. We see a lot of volume of traffic Tuesday, Wednesdays. Weekends are definitely slower. A lot of the issues that we have been having are, I would say, the majority are related to mirror. And we have sort of some nanny processes in place. So we realize the throughput goes down, and the mirror maker maybe is running, because RBS didn't say, look, the process is down. So the process is running, but it's not doing what it's supposed to do. Then you sort of do a forced restart. But when you do a forced restart, then there's always a chance that the offset commits may be off, and then which case you may have to so we are sort of a little bit careful about that. So depends. I think I would imagine of 8 people team that we always account for one person purely on call and not account for extra.